Hello, Namaste. I am Nikhil Khadkar. A warm welcome to Smart Solutions, where we mold and strengthen youth for academic and national prosperity. Hello, students, and welcome to Smart Solutions. We were discussing gravitation. Okay, so let us begin with gravitation, and this is our lecture 2. Okay, so in the previous lecture, that is in the lecture number 1, we have studied what gravitational force is, So what is gravitational force? Gravitational force is the force of attraction between any two objects. Okay, so that we have already studied, and also we have looked into some of the examples, like there were some tree and a car, and how gravitational force acts there. Also, the next example we considered was that Earth, Moon, Mercury, and Pluto, and how the force of attraction acts between these planets. Okay, then the second thing that we studied was properties of gravitational force. Properties of gravitational force. And there were 3 properties. Okay, so what was the first property? First property was that gravitational force is an attractive force. What is it? It is an attractive force. Okay, and the second property that we looked was this: what is the direction of gravitational force? Gravitational force acts radially inwards or towards the center of object, so its direction is radially inwards, or say towards center. And the third property that we studied was that gravitational force is a distant force, means it acts from a distance, so it is a distant force. Okay, so these were the points that we covered in the previous lecture, that is lecture number 1. To view lecture number 1, you can click on the icon shown over here. Okay, those who have not seen lecture number 1, you can click on this icon and you will be directed to lecture 1. Okay, so now let us move forward. So now we will understand what is circular motion, and centripetal force. Okay, so we will be looking at these 2 things now. So as you all know that if we are moving on a straight path, say for example this is our straight path, this is, say for example, our road, then it is said to be a linear motion. Okay, so this will be linear motion because this is a straight path, so linear motion, because we are moving in straight path. Okay, if you are moving along, say this is the road, and if you are moving along this road which is straight, then that is known as linear motion. But what if you are moving in a circle? Say if you are moving in a circle with this center, say for example if you are playing some, say for example this is boy 1 and this is boy 2, and if they want to catch each other, then they will be running in this direction and in this direction. Okay, and so now as you can see that they are running on the circumference of a circle, or rather on a circle, that is they are running on a curved path. Okay, so when any object is moving along a curved path, it is known as circular motion. Or when an object is moving in a circle, it is called as circular motion. It is called as circular motion. Okay, so now you have got the idea of what a linear motion is and what circular motion is. So I have a question for you, that say for example I will just draw that this is the surface of earth, and as you all know that the earth is a very big sphere. Okay, so this is our earth, or say earth's surface. Okay, with center say somewhere here. Now let us say that this radius, which I will call as capital R, is very much big as compared to say some distance, that is this distance or this arc, or I won't call it arc, I will say distance, because I am questioning you. So in order, or if I consider this distance, could you tell me if a person is moving from point A to point B, whether his motion is linear or circular? Okay, I am leaving this to you, that you have to answer that. If also one more condition I will give, that let us say that this distance is D, and here I would say that R is very greater than D. Okay, so this is the condition. And what I am asking that if this R, that is a radius of the earth or say sphere, is very much big as compared to the distance onto the surface of sphere, then when a person is moving from point A to point B, whether he is following linear motion or circular motion. Okay, actually this is the intention behind your chapter, that you should understand such things. So stress your mind and try to answer the question. Let us move on to now the next thing. So now we were looking into circular motion and centripetal force. So now we have understood what a circular motion is. So now let us look into centripetal force. What is centripetal force? Okay, in order to understand centripetal force, let us take an example, that a person is holding a string in his hand and he is trying to rotate that string. Okay, so let us say that this is a person and this is his hand. Okay, this is his hand, okay, and he is holding a string in his hand with some object attached. And what this person is doing, this person is rotating this string so that the object is in circular motion. Okay, so what this person is doing, this person is rotating the string so that object is in circular motion. So if you can see that the object is moving in this direction, okay, due to the rotation. So in order to rotate this string, what this person have to do, person is constantly applying a force on this object. Okay, this is our object. What this person is doing, this person is constantly applying force on this object. And what is the direction of this force? If you look at, the direction of force is radially inwards. Also you can perform this experiment or at your home, and you should perform it so that it is more clear to you. What you can do is you can just take any thread or say wire, you can tie some object to it, not very heavy and not too light, also a medium, and then you can just try rotating this object, and you will understand that in order to give motion to this object, we have to apply a force which is acting towards our hand or towards the center of the rotation of this object. Okay, so when we are rotating this object, the object is in circular motion. So now the object is in circular motion. Okay, so now let us say that this was the first position of object, then object is somewhere here now at some second position, then it comes to this position, say, so my radius will be this, or the line of action of force will be this, and it will again be towards the center. Now if you look, or what if while rotating, what we will do, we will just cut down the thread or the string. Okay, so now once the thread is cut, what will happen, this object will try to move out of this circle, it will be thrown outwards. But if you observe keenly, you will notice that this object will not randomly move anywhere. It won't go in this direction or here. It will have some specific direction. And what is that? And what is that direction? That direction will be tangential. Okay, it will be tangential to the point where, from where it was attached to center. Okay, so it will move in a direction tangential to the point where this string was attached to object and to center. Okay, and this is my tangential direction. Okay, tangential direction, and let us call this as a cut string. Okay, so let us say that if instead of cutting this ball at this position, if we would have cut this ball say at some another position, let us call this as the next position where we are cutting the object, then in which direction it would have moved, because see, this was the circular motion of the object, and after cutting, if the object was not cut, or if the object was attached to string, it would have followed this curve. Okay, but now as we are cutting this thread or object, it will move in a direction tangential to this point, and this is the tangent direction of its movement. Okay, so now as we can look from here that any force, okay, so this was our some force which we have applied for ball to rotate in a circular position. So any force which is applied on an object which gives this object a circular motion, a circular motion, and which is acting towards the center of its rotation, means this center. What that force is called? That force is called as centripetal force. Okay, so any force which is given to an object, due to which an object is in circular motion, and if the direction of this force is towards the center of rotation, then that force is known as centripetal force. So now let us try to write down the definition of centripetal force. Centripetal force. Okay, any force which is acting on an object moving in circular direction and acting towards the center is called as centripetal force. Okay, can you recognize some of the examples of this centripetal force where we have actually encountered this? Say for example, this is our Earth, planet Earth, and if now let us assume that this is our moon, and we all know that moon is revolving around the Earth. Okay, so let us say that this is the orbit of revolution, and now if this was the direction of its rotation along the path, and as we know that this motion, why is this motion? This motion is because of the force of attraction applied by Earth on the moon. Okay, so this is the direction of force which Earth is applying on moon, and because of this force which is acting towards the center, this moon is in a circular motion. Okay, so this moon is in a circular motion, and because of this force, this moon revolves around the Earth. So this is our first example. Now let us see what happens if there would have not been a centripetal force, of the centripetal force is cut off. So as in the case of previous example, what will happen? This moon will try to move outwards. Okay, so similar force acts between Earth and Sun also, because all the planets are revolving around the Sun. So Sun is applying centripetal force on each and every planet so that they are in the state of continuously circular motion around Sun. Okay, now so let us move on to next topic now, which is Kepler's laws. Kepler's laws. So for explanation of this, or for understanding of this Kepler's law, we require some fundamentals. Okay, So let us first look into the fundamentals, whatever are required. Let us take a cone. You all know that how a cone looks like. So this is our cone. Okay. So where do you find such shapes? Mostly you find such caps used for birthday celebrations. Second is your ice cream cake or ice cream cone, or funnel. It is of funnel is also of the same type. Now let us look at this cone. Okay, so now what we will do, we will try to cut this cone from this point. Okay, so we will try to cut this cone from this point over here. And now if we cut this cone, how is it going to look? So let us say that this is our plane where we are trying to cut this cone. Okay, so after cutting, if you see from top, it will be a hollow circle now. Okay, it will be a hollow circle now. And if you say, now if we cut cone inclined, here what we have done, we have cut this cone along this horizontal line. And now instead of cutting this cone in horizontal line, if we cut cone along, say, any of the inclined line, then what will happen? We will obtain something in this fashion. Okay, so it is inclined. Okay, so when we are cutting this cone in horizontal plane, this is circle what we obtained. And if we cut this cone in inclined plane, then this is ellipse which we will obtain. So let us actually take a cone and try to produce circle and ellipse out of it. Okay, so this is a cone that we have considered. Now what we will do is, let us try to cut this in this horizontal direction. Okay, so this is our horizontal direction, and we are going to cut this in this horizontal direction. And now after cutting, let us observe what the shape. So after cutting, let us observe what shape we will obtain. Okay, so what I am just going to cut this in the horizontal direction. Okay, and so if we again make it horizontal and observe from top, what you will observe? You will observe that this is circular in shape. Okay, so if you can notice that this shape is circular. So what we have written, that if a cone is cut in horizontal direction, we will obtain a circle. Okay, so now what we have to do next is, we will try to cut this cone now along some inclined line. So this was our horizontal. What does horizontal mean? Parallel to its base. Okay, so this was parallel to its base, and now we will cut this cone along, say, some inclined line. For example, say if I put this cone here, then we will cut this cone. Let us cut it along this line. Okay, So if you can see that this is the base and this is line which is not parallel to this base line, so this is inclined line. So now we will cut this cone in this inclined line or along the inclined line. Okay, so we have actually cut the cone now, and now we will observe what is the shape. So if you look from the top, okay, so if you look from the top, you will see that it is not circle anymore. Okay, so this is our previous cut which we have taken, which is circular in shape, not very perfectly, but it is circular in shape. But if you consider this case, then this is an ellipse. Okay, so now we have understood that how we can obtain circle and ellipse from a cone. This is our cone. Okay, so if we cut the cone along horizontal line, then we will obtain circle, and if we cut the cone in inclined plane, then we will obtain ellipse. Okay, so that's it for the day. Thank you. Admissions are currently open for academic year 2020-21. For all further information and for your queries, you can contact us on the number shown on your screen. And finally, I would say that to complete your education with flying colors, join Smart Solutions today. Thank you.